In this video, we'll look at the polarity for SF4, sulfur tetrafluoride. So we start with the Lewis structure. This is our Lewis structure. If you need help drawing the Lewis structure, there's a link in the description how to do that. Do note that we do have an expanded octet on the sulfur, more than 8 valence electrons, but that's okay. Sulfur can have more than 8. So with polarity, we're interested in how the electrons are shared in the bonds here, these chemical bonds between the sulfur and the fluorine atoms. We can see fluorine here is very electronegative, 3.98. Sulfur is 2.58. So there's a big difference in electronegativity. We expect that the electrons in these bonds here would spend more time with the more electronegative element. That would be the fluorine. So at this point, we know that the sulfur-fluorine bonds, they're polar bonds. But we really need to look at the molecular geometry to understand if the molecule overall is polar. So let's do that. So remember, we had 4 fluorine atoms. Let's put them here. 1, 2, 3, 4, and you see how they spread out to be as far away as they can from each other. And then we have a lone pair, and that lone pair is important because it's going to push everything down, and it's going to give us what's called a seesaw molecular geometry. So for SF4, we have this seesaw molecular geometry. Remember, those fluorines are more electronegative, and they're all on one side. That means that we have a polar molecule. So SF4, because of its seesaw molecular geometry, is a polar molecule. Let's go back to our Lewis structure. So to wrap up, we looked at the difference in electronegativity between atoms to figure out whether we had a polar or nonpolar bond. And then we looked at the molecular geometry for the overall symmetry of the molecule so we could figure out whether it was a polar or nonpolar molecule. In this case, SF4 is a polar molecule. This is Dr. B, and thanks for watching.